Welcome to lesson 2. In lesson 1, we spoke about basic phenomena in social sciences. We used some examples like differences between income levels, and we were interested in understanding why people earn different amounts, why people pay differently at their jobs. And then we said that we could have something like an independent variable that actually explains the dependent variable. Now we can think of that independent variable as variable x, and then we can think about the dependent variable as variable y, okay? The dependent variable of interest that we want to study, which is differences in income. To really make sense of the relationship between x and y, we really need a very good theory, okay? So as a social scientist, your work has to be theory driven and not methods driven, and not data driven as well. You want to have a very good theory of why x causes y, and then go out to test it, okay? Because remember, the main reason for statistics is to either describe the world or to predict phenomena, and we cannot predict properly if we don't really understand how our phenomena comes about. Okay, so it's very important to have some theoretical grounding in your causal relationship. To be able to achieve that, to be able to establish that causal relationship, there are 4 hurdles that we have to go through, and that is what this video is about. The first hurdle is there a causal relationship between x and y? Now let me not deepen my pen too much. Let me try this and see. Okay, is there a causal relationship between x and y? All right, before we can say that, for example, democracy increases economic development, or democracy leads to economic development, we need to think about whether there is a very credible causal relationship between democracy and economic development. Okay, because remember that the fact that things correlate does not necessarily mean that one causes the other. Correlation, if you don't know what correlation is basically let me define correlation in case you don't know what correlation is. So correlation is basically changes in one variable, okay, let's say changes in x, leading, no, I will not use the word leading, I will say changes in x, we also observe changes in y, okay, we also observe changes in y. So for example, anytime that sea levels increases, right? Sea level increases, bread prices also increase. And this is true. Anytime that sea levels increase, bread prices also increase. I have a very bad handwriting. Bread prices also increase. But there seems to be no sensible explanations to why increases in sea levels will lead to increases in bread prices. So there is correlation between sea levels and bread prices, but that does not lead to causation. It does not lead to causation. So causation is not the same as correlation. Correlation implies that changes in x, we also see changes in y. But the fact that this happens in the world does not mean that both variables have any meaningful relationship. And the truth is that a lot of things co-vary. A lot of things in the world actually do co-vary. So correlation is not causation. So then what is causation? Causation is simply x causes y. Okay? You can say that with correlation, x causes y. Okay? So the fact that two variables move together or sort of change simultaneously does not mean that x causes y. Causation is a higher level that has to be theory driven. So your causation should have a very good theory behind it why this actually happens. So that is the first hurdle that we need to go through. Is there a credible causal relationship between X and Y? And the second thing that is important that you should know before you go into your research design is that can we eliminate the possibility of reverse causation? Now, reverse causation is also a big threat, right? Is it possible, basically, is it possible that Y rather causes X? So if we are interested in the relationship between democracy and economic development, is it rather possible that economic development instead causes democracy and not the other way around? So if your theory is that X causes Y, but in reality, the reality is that Y causes X, then you have a big problem. So we should be able to speak to this and eliminate this problem before we test our theory. The third thing that we want to look at is that does X and Y co-vary? So first of all, you have a very good theory of why X causes Y. You are thinking deeply about the possibility of Y rather causing X, and you want to think about how you want to eliminate or mitigate the possibility of reverse causality. But the third thing is simply, is there a relationship between X and Y in terms of covariation? Covariation is simply does changes in X lead to changes in Y? Is there a meaningful relationship to that? And that also ties into your theory as well, where based on your causal mechanisms, you expect there to be a relationship between X and Y. The fourth is, and it is very, very, very serious, is the possibility of confounding variables. Okay, the possibility of confounding variables. This is important because how do we actually know that Y is not caused by some Z that we do not know about, right? For example, economic development, several factors contribute to economic development, right? Democracy, yes, democracy might contribute to economic development, but also quality of government can also contribute to economic development. These two are not the same, right? Quality of government is somewhere in the lines of state capacity, and that is different from democracy or regime type, right? Well, other factors might even contribute to economic development, like is the country a primary export, primary commodity producer, let's say primary commodity producer versus versus manufacturing, right? So several factors can contribute to economic development. You want to think about these factors as you move into your research design and look at how do I eliminate or how do I actually speak to these other variables that can affect the relationship between X and Y. So you are interested in the relationship between democracy and economic development, but you have to also think about if there is a potential variable, some Z, that either causes economic development or it even causes both. It can cause democracy, it can cause economic development as well. Without looking at the Z, you might have a very spurious relationship that is confounding scientific knowledge in, 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 in ways that is serious and undermines your research. So it's very important, and then you want to look at that as well. The last thing that I want to talk about, which actually relates to this fourth point here, is bivariate and multivariate relationships. Okay, so as we go along in our research design, you're going to see that your initial theory is something we call a bivariate relationship. okay, a bivariate relationship, meaning that there are only two variables in play here. So two variables are in play, your x and your y. The second thing is a multivariate relationship, which is usually the case because several roads leads to Rome, right? Every social phenomena is likely caused by more than one thing. So a multivariate relationship means more than two variables at play, okay, at play. So then we have our x, y, but we can also have a z that also causes y. We can have a b that also causes y. We can have a c that also causes y. This is a multivariate relationship, and we have to take note of that and factor it into our research design, especially when we are doing statistical analysis, so that we can isolate the effects that x has on y. We're going to talk more about this in lesson 3. In lesson 3, we're going to start from discussing probabilistic versus deterministic relationships, and then we'll move straight into talking about research design. So I'll see you soon in lesson 3. Don't miss it. Bye.